Okay, so I believe this was for Chelsea, looking at the assignment. Thanks for the email. You were looking at question 4 on the distribution of travel times. So let's go through it. So you've got a bunch of travel times on a section of road, and it's found to be approximately normal. So that's our key word, normal there, with a mean of 3.8 and a standard deviation of 0.4. And we want to draw a bell curve to represent this data. So step 1, let's get our bell shape in. And put a scale down the bottom. Now, a reminder that in the middle of the bell is always the mean. So that's our 3.8. I would normally put the numbers below the line, but I've been a bit poorly planned here. Standard deviation of 0.4. So keeping in mind, when we have our bell curve, our mean at 3.8, we need to do 3 little tick marks here to the right and 3 to the left. So you set up these bell curves the same every time. So regardless of the question, they'll always give you a mean and a standard deviation, and this is how you set it up. So we've got our mean here in the middle at 3.8, and we just count up and down by the standard deviation. So 0.4. So my first tick to the right here, 3.8 plus 0.4 is 4.2. And then I add 0.4 to 4.2, and I get 4.6, and then 5. When I'm going to the left, I take away 0.4, so I get 3.4, 3.0, and then 2.6. Okay. And keeping in mind, we've got so when we have our bell curves here, we have the 68, 95, 99.7 rules. So question 1 says, use this information to estimate the percentage of cars whose traveling times are between 3 and 4.6 minutes. Sorry, I had to cut there. So for part A, the first part here, between 3 and 4.6 minutes, we're counting how many standard deviations to the left is 3.0 and how many standard deviations to the right is 4.6. When I say that, I mean to the left and right of the middle here at 3.8. So I notice that 3.0 is 1, 2 standard deviations to the left. And 4.6 is 1, 2 standard deviations to the right. So I know, and these are just numbers that we need in our bound reference, that 95% of data falls between the first 2 standard deviations of the mean. So in between 3.0 and 4.6, we will have 95% of data. Okay, so we're back again. For part 2, we're looking at how many cars would be less than 3.4 minutes. So it might help. I've made a bit of a mess of my first bell curve. To draw it again, just really small. So we've got 3.8 in the middle, and 3.4 is the first standard deviation to the left of that mean. And we're interested in this section here. How many are less than 3.4? So this highlighted section here. So if you have we gave out templates of the bell curves with all the little percentages in it. If you have that, you could add those up. You'd have 3 numbers here to add up. But I don't have them, so I'm going to show you how I would work it out. So going back to, I might just do this on the back. When we have our bell curve, so it was a mean of 3.8 and a standard deviation of 4. to fill in my values. We want to know how many are below this line here. Now, reminder that in the middle we have 68. In this bigger section, we have 95. In the biggest section, we have 99.7. So if we wanted to break this down, and this is what you'll have on your templates, in between 1 standard deviation of the mean on each side, if there's 68% altogether, each side must be 34. Right. And for the next one, we've got 68 already accounted for. We need to get up to 95 including these. So I'm just going to do some by hand calculations. 95 takes 68. There must be 27% split between these two. So 13.5% either side. And then to get to 99.7, so we've accounted for 95% in this space here. Now there's 99.7 in between 3 standard deviations. So we need to do 99.7 take away 95. So there's 4.7%. So on either side here, we've got 2.35%. And on the last section, 0.15, either side. So I've recreated the template we gave you in class. So if we go back to the question, we were interested in how many are less than 3.4. So let's have a look. So 3.4 is here. We've got 13.5% plus 2.35%. plus 0.15%. Now, if you have a calculator, you can confirm this for yourself, but that adds up to a total of 16%. So 13.5 plus 2.35 plus 0.15 is 16%. So that's our answer for the second one. So 95 for part 1, 16 for part 2. For part 3, we want between 3.0 and 4.2. So going back to the diagram I drew here, and I might just leave it off to the side. So 3.0 is here. We need to go between 3.0 and 4.2. So we've got 13.5 plus 34 plus 34, which gives us 68 plus 13.5. Sorry if this is taking a while. I don't have a calculator on me, I'm afraid. So that's 81.5%. Let's see, so question 4 continues. So for part B, a car has a travel time of 5 minutes. So take a note. Determine the standardized travel time, the Z-score for this car. So just a reminder about Z-scores. So reminder about Z-scores. We get the Z-score by taking the actual value itself, subtracting the mean.
Sir Heath, if you're free, can you contact 103, please, Sarah? Call 103.
And then dividing by the standard deviation. So in this case, our value is 5 minutes. So I'm going to fill that in. 5. The mean is, so we can look back at the bell curve we drew, 3.8. and we need to divide by the standard deviation, which was given in the question, 0.4. So you get 5 take 3.8 is 1.2 divided by 0.4. Again, I don't have a calculator here. Actually, this is quite easy to work out, isn't it? 0.4 goes into 1.2 3 times. And we should expect that because 5 minutes is actually exactly 3 standard deviations above the mean. So we used the formula here, but really we should have just been able to tell. 5 is going to be 3 standard deviations above the mean for a Z score of 3. So B part 2. What percentage of cars have a travel time less than this car? So less than 5 minutes. So if we look at our curve here, it might be easier to just see, well, how many have more than 5 minutes? 0.15%. So basically, if we take 100% and subtract 0.15%, we'll get our answer. Otherwise, you could add up all these numbers. So 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5 and plus 2.35. But that'll get us to the same answer. So 2 options here. I'm going to do 100 take away 0.15, which will be 99.85% of cars have travel time less than 5 minutes. So taking our 5 and either adding up all of these numbers or just recognizing that we can do one takeaway, how many have more than 5 minutes travel time. Last part here, part C. We're given that the car has a Z score of 1.8 and we want to find the actual travel time, rounding to 1 decimal place. I don't have a calculator here, so I'm going to show the working out, but I won't show the final answer. So the formula from going from a Z score back to an actual score is the actual score, or the actual value, is the mean plus Z times the standard deviation. So this is an S, not a 5, just to be clear, for standard deviation. So our value will be, well, the mean was 3.8 plus our Z score is 1.8, and we're multiplying by a standard deviation of 0.4. So when you type this into your calculator, you'll get some number. 1.8, so it should be somewhere between 4.2 and 4.6. I would say we're expecting an answer around 4.5, but use your calculator to confirm. This was obviously a bit of a slapdash recording, but hopefully that was a bit of help for you. If you have any other questions, feel free to hit me up via email. Otherwise, enjoy your holidays. Thank you. Bye.